I already now get some applause. That's nice. Spasiba. So yes, that's about myself. Sebastian, born and raised in Munich, Germany, and I do a lot on enterprise software. And specifically in this presentation, I want to show you how to become a little bit more productive as developers, and especially how to build more productive development workflows. Especially if you work with enterprise software, especially Java Enterprise, but actually in general, if you use any type of coding, you just want to get a little bit more productive, and I will show you a few tips and tricks and specifically tools how to get there. So what I'm going to show you, I think slides are boring, so I will just show mostly live coding and doing a lot of demos and examples. And another information about myself, ja lubię coffee. So here's a nice comic for you. I think that describes me pretty well. So in a coffee shop, what size would you like? And B stands for, well, bathtub. So I have a coffee shop example for you, a coffee shop example application that I will build. And what I use Jakarta EE, Enterprise Java, Jakarta together with microprofile. So that is, I would say, quite advanced Enterprise Java technology. You can check out the website now built under Eclipse Foundation, compatible with Java EE, and you can check out microprofile as well. And what I will show you is just some live coding and that part, and then especially how to do that in an effective way. So what I have a Maven project, and what is already interesting, I do WAR file packaging, because, well, that's just easy and straightforward. But in general, what I want to do, I want to have thin deployment artifacts. So that is the first important thing for the workflow. So all the production dependencies are provided scope. That's what I use, Jakarta and microprofile, nothing else. And just because I'm brave, I use Java 12. Actually, I should change that to Java 13, right? Who uses Java 12 or 13 in production? Yeah, that's what I expected. Okay, anyway. So you can use that as well. So what I will show you first is just that default Hello World application for ordering a coffee. So what I have here is JAX-RES, right? It's a JAX-RES REST resource, basically that exposes something /orders via HTTP. So I can use JSON to, well, create a coffee order and get some coffee orders and things like that. And I want to start right away to, well, just build and try that out, right? Just to deploy it. So how do I build this? Well, if it's a Maven project, then it's easy. I do something like Maven clean package or Maven clean install, or maybe only Maven package without the clean, and so on and so forth. But anyway, that is the first important thing. That should run fast. Apparently my laptop is under load, so it should be actually less than 3 seconds. So I would say that's already pretty slow, 5 seconds. But anyway, less than 10 seconds. It should not take more time. Okay, so then I have a, well, thin deployment artifact. A WAR file in this case, or a thin jar if you like. That is pretty tiny, only kilobytes, right? Nothing more, because provided I don't ship my implementation, that is already an important part. Otherwise, the Maven build would take slower, right? And then, well, how do I run this? How do I deploy this, right? So what I will use, I use OpenLiberty. That is a modern runtime for Java Enterprise, for Jakarta, for microprofile, and you can use any Java E8 or Jakarta compatible runtime for this. But what I would do here, in this case, I could go and download it, right? But actually what I would do instead, I use Docker images. Docker is, I think, is everybody knows about it, right? Hands up, who uses Docker? Okay, most of you, I would say. So that's a Docker file. It's very simplistic. Important thing, you might know about the optimization of Docker file caching or copy on write file system layers. In other words, all the layers that you add should be tiny, should be small. So in this case, that deployment artifact, what you saw, is just a few kilobytes. So which is very good for optimizing this when building and when transmitting my Docker images. So actually what I can do is say Docker build this into an image. For example, call this image coffee shop, and there we go. We just build it, and very quickly, because just a few kilobytes. The same if I would transfer it. Docker push, it just pushes what has been changed, few kilobytes. Well, then I run it, right? Docker run, port 9080 is the default port of OpenLiberty, and then I can deploy the whole thing. So while I deploy this, basically can show you order coffee. If I would like to order some coffee, what I would need to do, I basically post some JSON here. So I would need to post an object like this that is binded using declarative mapping. So I would need to, have some coffee type and things like that provided. And once that is the case, I can go to, the command line, for example, or to my browser and use HTTP to access it, right? So something like curl localhost 9080 coffee shop orders to get the coffee orders. And of course, there are no orders in the system, so I get something like an empty JSON array, right? And in order to create some orders, I would need to, post some JSON to this resource, right? Very basic example. So let's do this. I have some, let's say, type espresso, some drink type for my coffee, which coffee would like to have. Я хочу espresso. And then I can go there and say, oh, great, now I have an espresso in the system. Okay, well, that's pretty straightforward. It just creates that. Easy. Basic hello world example for coffee. Great. Now, the point is, for my development workflow, you saw that basic example. It was quite quickly just to get started, to build and compile my application and to, run it in a Docker image. So now the point is, if I would like to change something, what do I need to do? Well, assuming I would like to change some code, I would need to, first of all, stop whatever is running here. And then, rebuild it, right? Using Maven. So again, I would need to do something like Maven clean package to rebuild my project, assuming I did some code changes. And then I would need to rebuild the Docker image, right? So let's do this. Rebuild Docker image, that is fast. I even have some caching here. And the WAV file is quickly as well. And then I would need to rerun it, right? And assuming that takes a long time, because what happens? You would need to execute at least 3 steps or more. So what should you do as a good programmer? Of course, you automate, right? You write an automation for it. So let's do something like this. Create a script for build and run. And then do something like, what you need to do. If I can start and build this on the command line, that's good, because then I put just all of the commands that I would write on the command line in my shell script and execute it, right? So do something like Maven clean package, Docker build, coffee shop, Docker run, -t 9080 or whichever port I have, something like this, right? Agree? Yes? No? Okay. Maybe? Dan yet neverné. Now what I have now is a script. It's a little bit better. At least I have a script that builds and runs it. But what happens in an office, right? You start this, and of course you take your coffee. Drink your coffee. Oh, it's still running. Okay, let's check some social media, Telegram, right? And then, of course, it might even be done, but now I'm distracted. And that's the problem, because I'm in front of my smartphone, or I check my emails, check Slack, check something else. And the point of programming is it's such a flow activity that, actually you want to write code, you want to build something, you want to create something, and then just stay in that flow experience, right? If it takes too long, if you have to wait, then you're out of that context, because you're doing a context switch, a mental context switch, right? It takes too long, you wait, you do something else, you are distracted, and this is where bugs happen, this is where you forget to do things that you just thought about, this is where you get bored. It's not that fun, right? So actually what I would like to do is to have a different experience where I just write something, I change some code, and I see the changes immediately being reflected. So I stop that again. And what I'm using in this case, and there are many, many tools and approaches out there, what I use here, by the way, all of these dependencies are just test dependencies. I use a Maven plugin for, in this case, Liberty, a Liberty Maven plugin. Typically, I have to say I'm not a big fan of Maven plugin overusage. I try to keep the tool simple and not use Maven to build the whole world, but use Docker to build Docker images. But that is an exception for development purposes. Why? I can start this with Liberty :dev, and what it does, it starts up Liberty in a development mode. Similar to what Quarkus also can do. Actually, it was part of Liberty for a long time, to listen to some file changes and to immediately reflect these changes in my running application, right? So if I change some code and if I execute unit tests, that's simple, right? But the part that takes longer is if I want to have some changes and the changes being reflected in an end-to-end fashion with the running application where I can go and hit the endpoint, right? So now if I wait for that startup, curl orders, okay, now it's up and running again. Let's post some espresso, okay. That works, and I can now go and see my coffee orders, something like this. Okay, great. Same application works again. I just, again, ordered the coffee. I hit the HTTP endpoint, and that works. Same story like before. Okay, nothing new. But now, actually, what I can do, I can code whatever I like. I can write some, new classes, add some new features in the server, and keep that thing running, and just change anything in my code. So, for example, what I had for now is just a Jakarta EE application, and now I will add some features from MicroProfile. If you have heard of it, there are some things like MicroProfile metrics for monitoring. I can add a health check, injectable configuration that complements everything that's in Jakarta EE, right? Because Jakarta, you might know about the history, it hasn't been involved for a while because of Oracle, now it's part of the Eclipse Foundation, and so on and so forth. And MicroProfile helps with that because we can use MicroProfile projects to, make that happen. So for example, what I could do, that is the MicroProfile umbrella dependency, and now I can add some things here. What is this? That is a server XML, but don't worry, it doesn't get much bigger than this. These are the features of Liberty, what it uses under the hood, but this is actually just an optimization. I could say, please use the whole Java EE, Jakarta EE, use the whole MicroProfile. But if I say, by the way, I only need JAX-RS CDI JSON, then it's faster, right? Because of the OSGI modules that it uses internally, it's just very quick to start up. So, you don't wait for half an hour, but just a few seconds. And in this case, what I can do, I can actually add some features. So, for example, MicroProfile Health 2.0. And, what it does, actually, and you will see in a second, I can change the features and also change and add classes while the whole thing is running. So let's add a health check, just a basic health check that uses MicroProfile Health. So what I do, I implement this health check and using the MicroProfile API. So that is just a very basic programmatic health check that checks for resource, whether my coffee shop application is up and running. I could check many things, right? Whether the database is there or some external system and things like that. But in this case, I want just to have the very basic example. So you see it also uses CDI standards and things like that. And now the thing is, if I add this health check resource and I have my process up and running here, then it will very quickly just redeploy my application in less than a second. And now if I go to the default health check resource, that's part of the MicroProfile health specification. It defines /health is, health check, okay. Sounds somewhat legit. Then I can check for that health check. Okay, so I just added this on the fly and I didn't wait because it says, oh, by the way, I changed something. It compiled the changes and just, swapped the individual classes that have been changed in my running Liberty. So that is what this plugin does. Listen for the file changes and immediately swaps it, which is very quickly. Also because Liberty is a very fast runtime. It can redeploy, as you can see, super quickly if I don't restart the whole thing, which is very nice for me because now I can just change something with data hello Joker. I add this, immediately will be picked up and reflected, and then I say I add some data, right, in my health check. So that's just some static code that I can add. So I can add this and change it, or Привет. And have these changes reflected as well. You have no clue how hard it is to write on a Cyrillic keyboard if you never learned this. And then you have that change reflected as well, right? So that works. We can add some more changes. So as you can see, I also add a feature, so it actually will listen to that, server configuration, because that's the convention where that resides. So I can say, by the way, I also want to have MicroProfile config being included for that, which provides injectable configuration. So same story, it will just, well, by the way, you add the feature, so I can on the fly install that feature, so you don't have to wait. And now I can use this feature. Let's say I want, what does microprofile config do? It gives me nice injectable configuration. So I can say what you know in Java E at inject, and then I write some config property that now comes from microprofile config, that annotation. And I say, oh, now please inject the configuration for the named key, for example, version. And then write some, version, inject this here, and actually use this version instead. So provide the version here, and oops, add it here in my health check. And then, of course, what you can see, again, same story, it will immediately reload, and then I have a version. So where does this version come from? Well, I have multiple default config sources that come with microprofile config. So for example, environment variables, very helpful for containers, or a default config properties file, microprofile-config properties, that includes that stuff, right? Nice story here with the tooling support is if I change something from 1 to 3 to 1 to 4, it will actually listen to these changes and update that as well. Because it knows, okay, that is the convention location, so it just assumes if you change the configuration, you want these changes to be reflected as well, which is very helpful. So you can do that if you want. All right, let's code a little bit more. What do you think? Let's add a little bit more features. So what I can do, for example, what is very helpful as well in a cloud-native environment, I can add some metrics, microprofile metrics. So what it does, if I add that feature, metrics, I don't even have to add some code or use an API. I can actually, out of the box, say, OK, for example, go to metrics, to that URL. And then what it says, oh, by the way, it is not allowed to access these metrics because it could be, sensitive data and whatever. To be honest, I don't care now. So I just change this to false. Again, same story. It will listen to these changes and then just update it. So what is this? That is looks a little bit weird. That is the metrics format, Prometheus format that it uses out of the box. If you know about Prometheus, cloud-native monitoring, de facto standard, so you can just use your Prometheus instances, point it to that resource, and then you can scrape some technical metrics. If you want not only technical metrics, but API, business metrics, so if you want to use an API, for example, what I can see here is, garbage collection information, memory, CPU usage, and blah, blah, blah. But if you say, OK, that's cute, but I want some business-related metrics, KPIs that actually tell me something about the users, about the application, like how many coffees have been produced, how many cars have been built, and things like that. What you would do in this case, well, you can also use the API. So for example, I can inject some metrics here. I can say, oh, by the way, that is my business component class, the coffee shop, and now I want to instrument, for example, this order coffee method. So I could have some counted annotation, just annotate the method, and then it will, well, literally just instrument the method invocations, coffees total, let's call this way. And then again, you can redeploy this, just watch for it, and well, now I would need to create some coffee again. Post. Create some espresso. Raz, dva, tri. And then check for the metrics again, and then you see, okay, now you have your custom metrics, your business-related metrics here as well with 3 created coffees and things like that. So you can inject as well a metrics, like inject an object that is part of the API that you can programmatically increase, and so on and so forth. So these APIs typically, like known in Java E, support some declarative approach and some programmatic approach. And again, the point is just of that nice experience. I'm changing, whatever here. I'm changing code, configuration, dependencies, and I don't want to wait for that update. So I want to just use an approach that for development purposes keeps something running, keeps my runtime running, and just updates that on the fly, right? Just because it's faster. You see, I don't have time to drink my coffee. I just, can continuously code and watch the updates happening right away. Okay, another thing that I want to show you a little bit more coding, a little bit more configuration to configure add some coffee prices. Let's add some features. So just to see that this also works if I, just add anything in my Java classes here. So let's add some in price for my coffee order. Never do primitive types in for money in real world, right? Don't do this at home. So let's add the price here. And then I, enhance this when I create some coffee order. So let's say, well, I want to have some configured price depending on the coffee type, right? And espresso is typically like cheaper than cappuccino or latte. So let's have some calculator for this. Price calculator. No, I cannot type calculator. And that is just a CDI component. I can say, okay, by the way, give me the price, get or calculate price. I cannot type calculate price, right? By the way, you check for typos and if I make some other mistakes. So then it's your responsibility too. So I give the coffee order here, and then, well, what I need, I say order get type depending on the type, and then I want some configured price, right? Like you can see here, I configured these, and now I cannot do an injection, right, of an injected property because it depends on well, whatever I do here dynamically, whichever type I have. So I can also do some programmatic lookup for this config API, actually. We price this espresso, for example. So I can say, oh, by the way, get configured price. Let's write another method for this. Create a method here. And what I can do, depending on the type, I can actually say return config provider. So I can do a programmatic lookup of this config and say, get a value or get an optional value of, well, let's outsource this, of a key is coffee price dot type name to lowercase, and that should be an int, and that will give me an optional. So let's say I want this, and in case it doesn't go back, then price 0, which is nice for the customer. So if my configuration doesn't work, the coffee is for free. Okay, anyway, whether or not that makes sense. And now I can use this here and say, by the way, if you create a new order, then please set the price accordingly to whatever, well, need to inject this to whatever my price calculator calculates. And then I go there, say price calculator, calculate for the given coffee order depending on the information, right? Agree? Didn't make mistakes? Okay. Again, I can go there and say, please redeploy my application so I can have a look. No orders in the system. Let's create a coffee espresso. And that has been created. And then I have a look and let's see what's happening. Oh, did you pay attention? Price is 0. That means there's some bug. Huh. Well, that's what happens when you live code. Everything can go wrong. But trust me, the same will happen to you as well. Right? Some bugs happen, you don't have tests. We'll talk about tests in a second. And well, how to debug that, how to see what's going on. Well, actually what we can do, what you would typically do, either you write a test for it, you look at the logs, you think very hard, or of course you use a debug feature in your IDE, right? That's what you typically would do. If you have a test, you can attach a debugger, run it in debug mode, and do the same here. You probably know you can also do a remote debugging, right? You probably have done that. If you have a remote JVM, if you have an application server running somewhere, you can attach to a remote debug. And actually the same works here as well. So, well, it runs in a debug mode, whatever you're running here. So that development mode starts up in a debug mode, and you can just say, oh, by the way, I can set a breakpoint wherever in my code, and then I can point my IntelliJ attached to process to running process per default port 7777. Do a remote debugging here, and then if I say, oh, by the way, I want to create a new coffee, then it captures, well, the execution here, and I can step through and I can see what's actually wrong and have a look at, okay, what's happening here. So I could go there and step inside and things like that. Oh, no, I did the wrong breakpoint. But anyway, did somebody pay attention? What was the error here? Well, I think you also see it in the log somewhere. It's, no, not in this case, coffee prices, so wrong configuration string. And why it didn't do any exception? Well, because I said optional, so if it could not look up that, it will just return with 0. So now coffee prices, we change it to that, and then it hopefully works. But again, that is just a helpful feature if you say, okay, something can go wrong, and then you can just attach a debugger very simply. So you don't even have to restart the server, and the debug mode is just right there, and you can use it. So that's very, very helpful, even if you run the actual server. You can connect to it using the same boundaries and just see the debug output and things like that. So that can be very helpful as well. Okay, now let's do some proper testing. Stop this again. Because what I showed you so far is just manual testing, and that can be helpful during development, but what you should actually do, and you know it, you should write some proper tests, right? And that also is part of the development workflow, because what we do, we write some code, and then we write some tests, hopefully, and then we execute the tests. And now the question is, how long does it take to run these tests? Because same story. Productive development workflows. We want to stay in that development flow experience, right? If we change some code and then we run a test and the test run for half an hour or for 5 minutes or even just 1 minute, what happens? Well, I get distracted, I grab my coffee, I check social media, and then here we go again, right? Whose Maven build takes longer than full build, not skipping tests, longer than 10 seconds? Hands up. Oh God. Longer than 30 seconds. Oh Jesus. Longer than 2 minutes. Longer than 5 minutes, come on. Okay, let's stop here. That's not fun, right? You start a build and it takes 5 minutes. I mean, who wants to wait for that? Okay, anyway. So, in the same way, like we write some code and we watch the file changes and we see something happening immediately, we also want to get an immediate feedback if we run our tests. We want to know right now whether it works or not. So the tests need to run quickly. That's quite easy if you run unit tests. I have one right here. That is a parameterized test for, in this case, deserializer of my coffee type. I can run this test, and actually I did run it when I did the Maven clean package. And, well, once IntelliJ woke up this morning, dobre utro, then it runs quickly. So if I initialize that, you see a few milliseconds. And actually the number of milliseconds here is just because of the initialization time. Cannot talk anymore. If you have a JUnit context and then you run plain JUnit, you can literally run hundreds of tests in no time, in milliseconds. JUnit, plain JUnit runs very, very quickly. That is a nice story. That is why I always tell people, use JUnit in a plain approach without any JUnit runners for JUnit 4 or without any extensions for JUnit 5. It will just run very, very quickly, especially if you test business logic, right? So if I do anything on a code level, that works very, very quickly here. Okay, now the more interesting thing is, what about integration tests, right? They typically take long. Typically integration tests, something like code level integration tests. If you use Spring, then it would be a Spring context test, right? Or for Jakarta, it would be a Killian or CDI unit. Any test runner that runs up a simulated or embedded environment that starts up your application in a somewhat simulated approach, and then you run the test with some, syntactical sugar that you can inject your beans already in the test and use them, and so on and so forth. So they are very pragmatic to write. But the point is, out of the box, they're not very effective because you have one and then you wait for 5 seconds, so that's okay, right? 5 seconds is already quite a long time, I would say. But the point is, it never ends with that. So what happens? Your colleagues come and copy paste your test to their test, and then you have 2 tests that run for 5 seconds each. And then at some point you have hundreds of tests, and then you end up with Maven builds that take more than 5 minutes, right? So typically that is due to integration tests or tests that run slowly in general. So what I want to do here instead, let's say I call this coffee shop IT default Maven convention for integration test. So the Maven Surefire, with Maven clean package, will actually not run this test, but only the failsafe approach. And now assuming I want to write a test that, for example, I don't know, system is up and running. So what I have here, and that is also another approach that I like to use, I have a, let's call this coffee shop system, which is a test dependency, which is a class that, well, resides in my test scope. And what it is, well, just a basic HTTP client. So this test driver will connect to my application and say, by the way, it offers APIs like, is the system up? Or by the way, create a coffee, or give me the application version and things like that. And then very quickly I can say, okay, test is system up. For some reason I cannot type today. Okay, coffee shop system is system up. I like to use assert J. That's, I think, one of the nicest assertion APIs. Come on. Yes, there we go. Assert that is, well, true in this case. Assert that the system is up and running. And another test, we saw system up test config app version, something like this. So given the application version and assert whether that is, well, the version that we would expect, right? Assert that a version is equal to 1, 2, 3. And now I can run these tests. And the reason why I would like to write tests in this way is, well, it just runs very, very quickly. Because what the tests do, it is a somewhat end-to-end system integration test, if you like. So it doesn't fire up something on a code level, but it connects to a system that is running, either locally, either somewhere else. And it just asserts, whether the system is up and running. That in this case, if you have a look into it, goes into the health check response and sees, well, whether the status is up. And the application version, which actually you saw fails because it's 1 to 4 and not 1 to 3. And that just runs quickly. In the same way, if I use this Liberty development plugin, it can also run my test if I just hit enter. And what it will do, it will run both my unit tests and my integration test. So it just very quickly tells me, by the way, you did a mistake. It's 1, 2, 3 and not 1 to 4. So in this case, I either need to change my test or I need to change, you saw this before, my configuration, right, in order to update that. So same story, I just update my code and then I rerun my tests, done, works. That is the development experience I want to have, right? I change something on the code, whether it's test code, configuration, production code, and then I want either automatically or just with one keystroke that verification of the tests being verified, telling me whether it's good or bad, immediately without waiting, right? And it works. Why? Because in this case, I separate, we can run it from the IDE as well, I separate the test lifecycle from the test environment lifecycle. So I don't say at test and please, fire up everything, because if you fire up everything all the time, it just takes, at least 10 seconds, 20 seconds all the time to fire up these tests. And during development, what I want to have is the experience that I want these tests to be executed quickly. And that only works if I have an environment that's already up and running. So now I see, okay, everything green, and I can continue, right? I can change something, write an end-to-end test, and it also tests the thing already in an end-to-end fashion. Later on, in my CI/CD pipeline, I can use the same test to test against, a properly configured deployed environment. That might be local or not, or somewhere else. I could point this driver to some other place, for example, using a system property, and say, now please, point to something else in localhost. And that just works here. I can do the same thing if I go to the command line and say, oh, by the way, I want to have Maven verify or something like this. Then I could run my unit test in this case, does the same like Maven package. So I run the unit tests here, and it might be slow because the other process is running. So Surefire only runs the unit tests, and if I would like to have just the integration test, I run fail-safe integration test. That's the Maven convention, because it's called IT, right? And then it just, well, executes these integration tests that go against my deployed application. Again, that is just the experience I want to have here. Okay. Now, it's quite easy if I only have one example that runs one application, right? Like this Hello World coffee shop application. I can run everything local. It's, a Docker container or not, or even just a local process. I can redeploy something. It's easy. It's almost too easy. So what I want to show you instead is a little bit more sophisticated example, my coffee shop that uses a few more systems. So What I want to show you now is a coffee shop where I already have some database integration, where I go and order some coffee, and then the coffee is not just stored in memory, but in a proper database. So that is already important for the testing or for the development workflow, right? Because if I run this locally, then I need an embedded database or a container and things like that. And I also will use an external system, like a barista. That's a friendly person who brews your coffee, right? So an external system that my coffee shack communicates with. And just to make it a little bit more interesting, not just in a synchronous, but in an asynchronous fashion. So I go to the coffee shop, I place the coffee order that gets persisted, and then later on, it will get updated in the barista. So my coffee shop, my coffee order status will be updated later on, right? So let me show you this. It's a different, slightly different project here. Shut down this example, and I go to my testing project. So that is a little bit more sophisticated. Has a coffee shop and has, in this case, well, a few more things that I fire up, and it also has a system test project. So actually, what I will do now, I will write a system test that tests my application, so similar to what I just did, but a little bit more sophisticated approach where I also need a database that runs, and in this case, a wiremark server. So what I have, my barista backend, I could deploy this as an external system, as an external dependency. But as part of this test, very similar to unit tests, I don't want to run the actual barista, but I want to run a mock, right? Same what you would do with Mockito, because I want to test the coffee shop application and not anything else. And then what I do as part of my system test, of course, I will kind of control that mock, the mock behavior, and also verify whether that communication was correct, right, between the coffee shop and the barista, whether that was done correctly. So I verify that contract to see whether everything works. And that's a little bit more complex and a little bit more interesting to do that also in a local environment. Because now what I want to avoid to run that solely in the continuous delivery pipeline, right? Because typically what happens, you write something like this, and then you build up a proper environment, right? Like a test environment, a staging environment, and then you write some proper system tests for these environments. At least you should, I hope so, right? System testing, end-to-end test everything in a proper environment, good. Everybody's nodding. But then what happens? Well, I write my test, I write my code, I change something in the code, and then I do a git commit and git push, right? Then I wait. How long does the CI/CD pipeline take to execute? More than 1 minute? More than 5 minutes? More than 10 minutes? Okay, anyway, too long. So if I would commit something and then wait for these 10 minutes, I can make for coffee, I can go for lunch, whatever. But that is not even the problem. The problem is I commit something and of course it doesn't work, right? As you saw before. I make mistakes continuously. I cannot even type properly. So then my colleague comes and says, Sebastian, нет, не работает. Again, does not work, of course, right? And then I'm like, oh my God, that's so embarrassing, and I try to fix it. So git commit, git push. I wait 10 minutes, 20 minutes again, and again, does not work, right? And then you see the build history, green, green, red, 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 green. That's what happens, and it takes a long time, and it's super embarrassing because all your colleagues see, what crap you committed into the history. So again, I want some way to verify that a little bit more easier how that looks even in a more sophisticated environment running at least 3 applications or more. So what I want to show you here is, well, a system test that basically fires that up. So I will just fire that up here. In this case, I prepare something in shell scripts that basically builds that coffee shop application, and then I start up a test environment in, well, whatever technology you would like to use. So I use Docker containers just because it's easy to build them locally without downloading a lot of stuff, and to run environment and to execute them. Then I run 3 containers, as I will see in a second. So I have Docker PS, now 3 containers up and running. I could also use Docker Compose or whatever technology you might want to use. You can run them as 3 standalone processes, whatever. A coffee shop and my wiremark for the barista. So that is not the actual Barista backend, it will be that mock server, right? And a database. I could also use an embedded database or so whatever makes sense for your local development. But basically, I set up local running containers. If you're really cool, you can also set up a Kubernetes cluster locally or even an OpenShift cluster. That works as well. Similar approach. You have something that is already connected locally that you can use for tests. And in this case, then what I do, so this is already up and running. And now I run a similar Liberty development plugin approach here to basically go to my environment as well and say, oh, please give me now that application that runs on a different port. You might have seen that because now I have multiple of these. And that just gives me, well, in this case, a default response. So I can go to resources/orders. This responds a little bit differently and see, okay, now there's no orders in the system. And, same approach, but now I have that system test environment where I can actually say, please write this in test. Okay, how do I do this? Because it becomes actually quite sophisticated now. I write a test, a system test, and now that's already a good lesson for writing maintainable tests. What you saw in my other project, the IT, what I did, I separated the test scenario from this driver. I defined a coffee shop system and I defined a coffee shop IT. And the IT uses the system. Why? The other delegate includes the information, how I connect to my application, how I create that coffee, how I check about the version, right? Because that uses HTTP, that uses JSON and all these lower level details. If I would put all of that in a test, in a single 200 lines of code method, this is not really maintainable, right? Because then my test scenario information is buried somewhere, and if I need a new scenario, well, what happens? You copy-paste these 200 lines of code into a new method, and then you do that a few times, and then you can throw away your test if something changes, because nobody has the overview of what happens here. If you write it in that way, then it becomes a little bit more maintainable, because if I say, how does my create a coffee order and verify it look like? Well, it's very readable. I go and say, oh, please, create a new coffee order with espresso. Now, this system includes some origin, like bean origin, espresso from Colombia, from Ethiopia, from some exotic country. And coffee order system, please create that order. How it is done, well, I don't care. That's part of that, other dependency. And now afterwards, give me the order again, and now verify whether the information is correct. Stuff like that. So that is a little bit more maintainable. And if you are interested how that works, well, you look into the other dependency and you see, HTTP client, JSON mapping, and so on and so forth, status code verification, and all of that. So I can execute this, and then I see, okay, same story again. Well, this is just a very basic test, but it runs quickly. Because same story, it just uses an HTTP client, it connects against something that is already running. Now what is more important, so that's boring. What is a little bit more interesting is having a test that now uses this wire mock. Because now I have actually multiple status transitions. So what happens, I go and create a coffee order, and then it happens asynchronously. So the best thing I can do in my test is, wait, right? So I create the coffee order, and then I know, ideally now something is going to happen. So I need to wait for that execution. I need to wait until my coffee shop calls the barista backend. Because it's asynchronous, I don't know whether that happens immediately. So what I can do, I also use another delegate for the barista system that now acts as a mock, right? So if I look into this, well, this uses actually wire mock to say, oh, please, connect to that system and set up wire mock. That's very, very similar to what Mockito does on a code level. Now it's on a system level. It's like, an HTTP mock server. I go there and say, please respond in this way. Now please respond in that way. Or verify whether that communication was correct. So, please answer for this order that is about to arrive in this way to update that status. Okay, so now the order should be preparing. Okay, then I get the information, check whether that's the case, and now I have to wait until that invocation happens. So that's the best I can do here. I wait with a timeout to assume, okay, it should happen within, that time frame. So that's the best I can do. And then, well, wait for that invocation. And afterwards, I know that there needs to be another status transition. That's part of my business logic. Because at first I create a coffee, then it needs to be prepared, and at some point the barista guy is finished, right? And then at some point it will be actually collected and handed out to the customer. So I can do this, and then I just basically, let's execute it. I go to these two systems to just do that communication. So even in a more sophisticated setup where I have a database and an external system, that works. Now this takes a little bit longer. Why does it take longer? That's actually not the fault of the test. That's the fault of the business use case. Because it's an asynchronous approach, it actually waits always 2 seconds with a timer until it updates my status. So that is okay if that takes longer. But again, the test itself starts up quickly, and I can parallelize all of that. If I write my system tests, these tests, in an idempotent way, right? So where they just can connect to the application and just try this and then try the other one, verify these use cases. Your users in production do the same thing, right? They also don't care whether there's another user, they just connect. So you can define your test scenarios in a similar fashion and then just run them. But the point is, again, even if I have a more sophisticated setup, that just works in this way, and I can set up that very effectively, that I say I can write some code and I can change it. Because that coffee shop now also runs in this Liberty development mode, actually, inside a container. So what I can do, I can go and, where's my curl? I can go to this resource page and see, okay, I have this response, right? That is emitted from a root resource here and built using JSON-P. So I can say, okay, build this for the index. Looks quite big with the hypermedia resource. So again, I can say, hello, Joker. Same story. It just will update very quickly, and then I see the response right here. Hello, Joker, or I change it, and so on and so forth. So that is just, the idea to have that thing up and running. And now same story, I can go and re-execute my system test, test it manually, write a system test for it and execute it all the time. It just happens quickly. Even in an approach where I have a more sophisticated setup using multiple systems. If I use a technology such as containers that I can build up locally. Okay, assuming I have a setup where for some reason, what I actually would like to avoid, but where I have to test in my proper staging environment or my proper whatever somewhere environment, because of something that is not available locally, because of an external system I need to use, some authentication or some mechanism that is a little bit more complex where I cannot test that locally, right? So then I have the same problem. So for example, something is running on, who uses Kubernetes? Okay, a few. Well, let's do something running on Kubernetes. I have actually a Kubernetes cluster, multiple of them. How you get a Kubernetes cluster? Well, multiple ways. I use a managed one from IBM Cloud that runs here. And oh, by the way, I can update my cluster, production cluster, but not right now. So then you can use kube control to access your cluster, right? So assuming I have something up and running in Kubernetes, so if the Wi-Fi works, I get my coffee shop. So I actually deployed the application, not this one, but the previous application in my Kubernetes cluster. And now what I would like to do is, well, I have a Kubernetes coffee shop here up and running, so I can access that. I can say, go to that using, well, the proper mechanism of my staging environment or production or whatever that is. But now what if I want to debug something there or test out something there or change something here right now? What I would need to do normally is to take, again, the full CI/CD pipeline to change my code and then let it deploy into this environment. That is what you should do, right? Using your proper pipeline, and then change it and test it. But same story. You remember my colleague, right? Making fun of me for doing mistakes. So then again, you would need to do that pipeline that just executes slowly and where, well, you do mistakes. So there's some other tools available. You just need to, well, depending on what technology you use, that is telepresence, which is a helpful tool for, well, Kubernetes that sets up, well, a proxy for test and debug purposes into your cluster where I can test and debug individual applications with something that runs locally. So assuming, let me start up that example from before again, LibertyDev. I hope I stopped everything else. Yes. So I start up my LibertyDev environment locally again, so I can go and say, okay, curl localhost, what was it? This one. Once that is up and running, so I have my empty coffee order example, and I could post and take some order. But now, again, I don't want to test this locally, right? It's cute that this process runs locally again. We saw it before, but I now want to test it, running in the cloud. So what you can do, actually, you can run this telepresence tool to say, okay, telepresence, please connect to my Kubernetes cluster and take that Kubernetes deployment. If you use Kubernetes, you might be familiar with that. Basically, the running application that runs in pods, in containers, and swap it with something that runs locally. For example, with something that runs under port 9080. That, by the way, is my locally running process, my Liberty application. So what it does now, it will go and actually go and swap my poor application with something else, with a two-way proxy that proxies everything that arrives at that application to my laptop here. And then once that is the case and up and running, what I can actually do, I can go to the normal cluster IP, to the boundaries. Let me run my secret script to get the IP of my public accessible IP of my Kubernetes cluster. And then say coffee shop orders, right? And go and access that as well. So I can have my coffee orders, and I can post my orders here again, right, like I did before. And then I can create something that actually runs in my Kubernetes cluster, but the process that is running actually runs in my on my local machine. So that uses the same example, but it actually tests something that runs in the cloud. And now that application can also use things that run in the cloud because it's bidirectional proxy and access all the other Kubernetes services, for example. Or the other way around, if I would like to debug something that I access from here in the application, well, what I can do again is to go to my code here and say, just what I had before, where's my orders resource? I can go and set a breakpoint here, and then again, point my IDE to the locally running process, attach to process 7777, and fire that up. That actually uses the public IP. So if somebody would like to access my staging environment, I can debug that thing locally here and step through these breakpoints and then see what is happening. So by that, I have a mean to even debug and test something that is running somewhere else, in this case using Kubernetes, but basically using a same approach to just be faster to test that. And as you can imagine, if I change some code here as well, then same story before, because it literally uses that process that runs locally. Works similar with containers. So I can set something up, and that just works here. So that is the whole point of this talk, is to, well, just use some tools and some approaches to get fast feedback, to stay in that productive environment, to, well, use the tools you have with an approach where you just a little bit more effective. So as a takeaway, you want to keep your turnaround cycle short. And with short, I mean literally less than 5 seconds. So what you saw before, in, for example, changing that code, changing configuration, and then just seeing that being updated, it literally updates in less than a second in Liberty typically, and at least using your IDE, change the file, save it, it should run in less than 5 seconds. You can do the same, including, well, what you see, compilation, including unit testing. That should be simple. Only if you use plain JUnit or an approach where I can run many tests in still no time. So that's important. But even using something that tests your application in a more system test fashion, in an end-to-end approach, right? Where you already can connect to these boundaries, to these resources, and see the proper response using HTTP, JSON, or whatever, right? by basically having some type of hard deployment approach, whatever you use. So I use Liberty for that. There's a tool called JRebel. You can do that even with some, lower level JVM mechanism. So it's not, it's not magic what it does. It's just a little bit more integrated. Actually, Liberty could do that for a long time using the loose application mode, what it's called. And then you literally can swap compiled classes. And what it does, it detects that file change and then just, redeploys the application, which happens very, very quickly, as you could see, typically less than a second. And that is just so much helpful for our development experience that we don't have to restart that whole thing. For tests, it's really crucial that you regard these test life cycles, that you say, okay, at least during my development workflow, my development routine, I don't want to set everything up each and every time. It's okay if I go to my development environment in the morning, say, Dobre Utra, I take some coffee, I set it up, I wait 5 minutes, and if it even waits, it takes a while to set it up locally, that's okay. But while I'm there in front of the keyboard and while I'm developing, I want that to happen quickly. I don't want to wait 10 seconds even each and every time to wait for that test execution and to set up that simulated environment. That takes too long. I want that to happen immediately. Doesn't matter whether it's locally, in Docker containers, in my Kubernetes cluster, somewhere else. I can set up something up front, but then it needs to happen quickly. Same for tests. So the tests ideally just use something that is already there. If it's an end-to-end test, then just a client that literally starts up right away. I don't want to start the server on the test start because that always takes a while. Technology is getting better and better. Spring is super fast in startup. Jakarta is super fast. If you use a modern runtime, you saw a few seconds. But even these few seconds is just too slow for immediate feedback. You want feedback right away. And that only works with something that's already running. So have a look at the development workflows that you can set up locally, in all kinds of ways, and really depends on your technology, but there's always a way to do that. You can be creative, you can hack your way around, using whatever mechanisms to do that. And this is actually not against the idea of continuous delivery, it's complementary, right? So I'm not telling you do this and then you don't have to test, in production, or you don't have to do that in a CI/CD pipeline in a proper approach, but you still should do that. But it's a way to get faster feedback. That's complementary. Because as I told you before, if you don't do that local development workflow, that optimized one, it just takes so long because you always have to commit and push. You always have to wait for the CI/CD pipeline. You always get embarrassed in front of your colleagues. That's not productive. So what you do such an approach locally, and once you are in a state where you say, okay, now, работает, this works locally, I can have my test, I have a system test, now I commit and push it, so now my proper CI/CD pipeline runs while I get another coffee or code the next feature that has its proper test where it deploys to another Kubernetes, where it deploys to its test and staging to a proper environment. Not that Liberty Dev development mode, because you never know whether that is 100% the same in production, but it's very close. So you can be very sure that it works there as well. But then you get the ultimate verification in that pipeline, whether or not it works before you deploy to production. And that's complementary. But the point is, it's much more likely that later on it works if you tested all of that in an end-to-end fashion locally, using containers or whatever, right? And then later on, you're pretty sure that that works, and it's much more effective to use, and especially because of that time. You saw what many things you can do in no time if you have an effective development approach. And I believe, because programming is such a flow activity, that is also just much more fun to program and fun to use. I hope that was helpful. Спасибо большое. Thank you very much for your attention.